Welcome everybody. Our new topic is polymers. In the polymers we have to be learn the introduction about the polymer, classification of polymer, then formation of polymers, preparation of polymers. In the polymers you have to be learn their properties and uses. So this is the one of the important topic in your syllabus. So today we are going to start the topic polymers. Now see the introduction of polymer. Polymers is the Latin term or Greek root. It is a combination of the two terms. One is a poly and second is a mers. The meaning of the poly is a many, or it is also indicates the large. Mers indicates the parts. So in the polymer, small repeating units combined together and you will get here a large molecule. Therefore these are also known as macromolecules. But remember the one important thing here, all the macromolecules are not polymer. See the example, chlorophyll. Chlorophyll is a macromolecule but not polymer. Small and repeating unit in the polymer is known as monomer. The process of preparation of polymer or synthesizing polymer is known as polymerization. Example, polyvinyl chloride, polythene, these are used in your day-to-day life. So I will take the number of Nylon 6, Nylon 66, Terylene, bakelite, all these are the examples of polymers. We should know the inorganic polymer. Glass is an inorganic polymer, concrete is also inorganic polymer. The number of times of the monomers that are repeated in the formation of polymer are known as degree of polymerization. Now we are going to learn here the next point, that is classification of polymer. Classification of polymer. This is the one of the important point. I will do the summary here, and from that summary I will explain. These are based on the 6 points. This is based on 6 points. So I will explain here the classification of polymer. That is based on the source, based on process, based on properties. So this is the point here. Polymers are classified on the base on. See here, polymers. These are classification based on the source. So this is, I will write here the common term, based on source, and these are classified into 3 types. 1, 2, 3. One is a natural polymer, second is a synthetic polymer, and third one is semi-synthetic polymer. Semi-synthetic polymer. It is also known as a regenerated polymer. Then second one, based on the point structure, source structure. These are again classified into 3 types. First, second and third. See here, first is a linear, second is a branched, linear polymers, branched polymers, and third one is a cross-linked polymers. Then third one is based on the points intermolecular forces. This is the important point here, based on intermolecular forces. Intermolecular forces. One is elastomers, second is thermoplastic, then thermosetting, and last one is a fiber. Then next one is based on polymerization process. Based on polymerization process, these are first addition polymers and condensation polymers. Only two types are there, addition and condensation polymers. Then number of monomers. So these are again classified on the basis of number of monomers. Number of monomers. These are classified into two groups. One is Homo Polymers. Homo Polymers. And second is Heteropolymers. Now last one is based on biodegradable, and that is biodegradability. Biodegradability. These are classified into two types. One is biodegradable and second is non-biodegradable. So these are the points here. So 1, 2, 3, 4, 5 and 6. And see, these are the on the 6th point. First is the source, that is from which they are derived. They are classified into three types. One is natural polymers. You know the natural polymers are two types. One is plant, and it is also called as vegetable, and another is derived from the animals. You know the plant, that is cellulose, starch, then hemp, jute. These are the derived from the plants. Animals, that is the silk and wool. These are the animals. Synthetic polymers, these are man-made polymers. Man-made polymers. See the example of the synthetic polymers: Nylon 6, Nylon 66 or 66, Terylene. These are the examples of the synthetic polymers. Semi-synthetic polymers, these are also called as the regenerated polymers. In this case, the natural polymers, on the natural polymers some chemical process or reaction is performed so that the properties such as tensile strength, appearance is developed. Therefore the term semi indicates partial or one half, 1/2. Therefore these are semi-synthetic polymers. Then second type is structural classification based on the structures. These are classified into three types similar to the source. One is a linear polymers. In this case, longest chain will be present. There will be no side chain. All the elements such as carbon, hydrogen will be present in the straight chain. Therefore, they are called as a linear polymer. Branched, the example of the linear polymer is ethylene, polyethylene. So this is the example here. Then branched polymer, in this case side chains are present. See example isobutylene. In isobutylene, on the second carbon atom one methyl group is there. Isobutylene is the example of the branched polymer. Then cross linked polymers. Cross linked polymers. In this case, the branched polymers sulfur is added and cross linking will be there. Therefore, there is a cross link. And best example of the cross link polymers is the bakelite. Then come to the point intermolecular force of attraction. These are classified into again 4 types, that is elastomers, thermoplastics, thermosetting and fibers. Here one of the important question: arrange these compounds in the decreasing order of their intermolecular forces. Suppose I will give here A, B, C and D. Among these, which has the maximum intermolecular forces? D. Minimum elastomers A. So see here, if you try to stretch the fiber, that will be break. It is not elongated. Therefore, it has a maximum intermolecular force of attraction. And then if you consider the last one, elastomers. Elastomers indicates that is the elasticity. Best example is the rubber band. The elastomer example is the rubber band. That has a minimum intermolecular force of attraction. If you give the stretch, that elongated, if you remove the stretch, that will come to the original position. Therefore, they have the intermolecular forces. Then here C and last one is B. So this is the important question. This is the decreasing order of intermolecular force of attraction. Now I will explain the term thermoplastic and thermosetting. See here, this is a setting and here is a plastic. Thermo is a common in the both cases. Now plastic itself indicates when you will heat the thermoplastic, that will be molded, that is will reused and again reshaped. Therefore it is called as thermoplastic. Thermosetting, if you try to use again and again, it will not use again and again. Then fibers, we have the maximum force of attraction. Polymerization process, classification based on the polymerization process. These are classified into 2 types. One is addition polymer and second is condensation polymer. The term addition itself indicates the monomer must be unsaturated. It must contain double bond or triple bond. So in this case, only addition will be take place. Removal of the small molecule will not be take place. And the best example of this is a polyethylene. That is Hdpe and Ldpe, high density polyethylene and low density polyethylene. These are the examples of the addition polymers. Now condensation polymer. The term condensation itself indicates the monomers contain bifunctional groups or trifunctional group or polyfunctional group. In this case, first nucleophilic addition reaction will be take place and then removal of the small molecule such as alcohol, water will be take place, and therefore this is called as a condensation polymers. Then point number 5, number of monomers. Homo indicates only one, single. Homo indicates only one. Hetero indicates different. The polymer which is formed by the combination of only one type of the monomer, it is called as Homo Polymer. Example here, polyethylene. It is formed by using only ethylene. Heteropolymer, which is formed by using the 2 or more different monomers. Example, Nylon 6, Terylene. These are the examples. Then point number 6, classification based on the biodegradability. These are classified into 2 types. One is a biodegradable and second is non-biodegradable. The polymers which can be decomposed by using the microorganisms such as fungi or cells, that are called as biodegradable, and that which cannot be consumed by the microorganisms, that are called as non-biodegradable polymers. So we completed 2 points, that is classification as well as introduction of polymers. So take the brief revision on the introduction of polymer. Polymers are classified on the basis of 6 units. First is based on the source, that indicates natural, synthetic, semi-synthetic. Second, structure, linear, then branch and cross-link. Third one indicates classification based on the molecular forces These are the four types that molecular forces are: elastomers, fibers, then thermosetting and thermoplastic. Then based on the mode of polymerization, condensation polymerization, addition polymerization. So these are the classification of the polymers. Now we are going to learn here in detail the preparation of the some polymers. Preparation of some polymers. First consider the point here, that is addition polymers. Preparation of addition polymers. Point is preparation or synthesis of addition polymers. I was explaining the term addition. The initial monomer must contain the multiple bond, that is double or triple bond. And see the examples of the addition polymer. You have to be learned here 4 addition polymers. So I will write here that 4 addition polymers. One is Ldpe, low density polyethylene. Second is Hdpe, high density polyethylene. The next one is a polyacrylonitrile, shortly denoted as a PAIN, polyacrylonitrile. And last one is polytetrafluoroethylene, polytetrafluoroethylene, which is also known as Teflon. So you have to be learn these in details. So in this case you have to be learn the preparation, that is a synthesis of the 4 addition polymers. So see the first addition polymer, that is Ldpe, high low density polyethylene. So remember that in this case the monomer is ethylene. Ethylene is a common name. Its IUPAC name is ethylene. This is the IUPAC name. So in this case you can also call as a polyethylene or polyethylene. Now write down the preparation here. You will take here the N molecules of the ethene. CH2 double bond CH2. This is ethene. It will undergo polymerization at a temperature 200 to 300 degrees centigrade. Process is polymerization, and this process of polymerization is carried out in presence of oxygen catalyst, and temperature as well as pressure is high. It is 1000 atmospheric pressure. So you will get here, that is a polyethylene. CH2 single bond CH2 CH2 CH2. Shortly it is denoted as N. Then here branching will be take place. In this case you will take here this CH2 CH H CH2 CH2 N type. Then it will react with the second free radical CH2 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 CH2. And see here, this is the free radical. It can abstract here. This will be shifted here, and you will get the branched polymer. And therefore, this is a branched polymer. Branched polymer. And therefore, density is low, as the surface area will be decreased. Therefore, density is low here. Now see here, it is a branched polymer. It have low melting point. Second important point, it has low melting point. You know that as the branching increases, melting point and boiling point decreases. These are chemically inert. So next important point, these are chemically inert. Inert means not reactive, and also these are very tough. Therefore, these are used for transparent polyethylene or poor conductor electricity. Therefore, it is used in the insulation cables, packing bags. then marking bags and flexible pipes. These are used in flexible pipes. So take the brief revision on the title. Ldpe, low density polyethylene. Monomer is a ethylene. So main molecules of ethylene undergo polymerization at high temperature and pressure. It is a branched polymer. It has a low melting point. It is chemically inert and tough. Therefore, it is used in the preparation of packaging bags, insulation cables, making the toys and flexible pipes. Now we are going to learn here the second one, that is high density polyethylene. So give the title, second one, high density polyethylene, HDPE. Second one, HDPE. High density polyethylene. Now in this case, one of the important point here, same monomer is here, CH2 double bond CH2. It is ethene. It is, this question is important here. It is carried out in presence of Ziegler-Natta catalyst. Ziegler-Natta catalyst. Now, Ziegler-Natta catalyst is the mixture of titanium chloride TiCl4 and aluminium triethyl C2H5 type. So this is carried out in presence of titanium chloride and triethyl aluminium. Titanium chloride, triethyl aluminium. Your role is catalyst, and you will get here the structure CH2, 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 4 N time, and this is called as high density polyethylene. It is coordination polymer because first ethylene forms a complex with the titanium chloride. Hdpe is a linear polymer, therefore it has a very high density and high melting point. Therefore it is used for making the bottles, jars, buckets, drums and pipes. So these are the important points here. So we completed the term, that is HDPE and that one, HDPE and Ldpe. Now third one is polyethyl nitrate. We could take the revision on the HDPE, high density polyethylene. Here monomer is a ethylene. This is the important point. Second point, it is a linear polymer. As it has highest linear surface area, therefore it will have high melting point and boiling melting point here. Therefore here another question, it is carried out in presence of Ziegler-Natta catalyst. Ziegler-Natta catalyst is a titanium tetrachloride and triethyl aluminium. Triethyl aluminium. It is a linear polymer, therefore it is used. It is very high tensile strength. It is a tough and hard, therefore it is used for the preparation of drums, bottles. Now second important, third one, PAN, polyacrylonitrile. Third addition polymer, polyacrylonitrile. It is also known as acrylon. It is also known as acrylon. It is also known as Orlon. It is also known as Orlon. Here monomer used CH2 double bond CHCN. This is the monomer, and the name of the monomer is acrylonitrile. Acrylonitrile. This is the monomer. It is also known as vinyl cyanide. The IUPAC name of this acrylonitrile is pro-2-in-nitrile. Pro-2-in-nitrile. Now these are the question on the monomers. Now reaction. This acrylonitrile can also be written as here CH2Cl. N molecules will be there. It is process is a polymerization process. It is carried out in presence of oxygen catalyst at a temperature, high temperature and pressure. Therefore, N molecules will be combined here. We will get here CH2CH double bond N Cn, and that is called as polyacrylonitrile. First point, it is addition polymer. Second important point, it is a Homo Polymer. So these are the important points here. Now uses, it is used in making the blankets, artificial blankets. Use here artificial blankets or shawls. These are used for the artificial blankets or shawls. So we completed Ldpe, Hdpe, polyacrylonitrile. Revision on the polyacrylonitrile. It is also called as acrylon. It is also known as orlon. Monomer is acrylonitrile. Formula CH2 double bond CHCN. It is also known as vinyl cyanide or vinyl nitrile. IUPAC name is a prop-2-enol. See here 1, 2, 3 carbon atoms are in a straight chain. Therefore, derivative of propane double bond starts from the carbon number 2. Therefore, 2-ene and nitrile is there. See, this is the reaction. It is carried out in presence of oxygen catalyst. It is addition polymer. It is a Homo Polymer. It is used in the preparation of artificial blankets. Now, give the title here: polytetrafluoroethylene. 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 PTFE. Polytetrafluoroethylene. It is also known as Teflon. The monomer used in this case, tetrafluoroethene or ethylene. Structure of this one, CF2 double bond CF2. This is addition polymer. Next one, it is a Homo Polymer. So these are the primary question only on the title. Reaction, CF2 double bond CF2 tetrafluoroethylene. It undergoes polymerization. You have to take here N molecules. So write down here polymerization carried out in presence of oxygen catalyst at a high temperature and pressure. You will get here CF2 single bond CF2 N type, and this is called as polytetrafluoroethylene. Now see, it contains 4 CF bonds. These bonds are very strong because fluorine is a highly electronegative. Therefore, that cannot be broken. Therefore, these are very hard, and therefore these are chemically inert, and therefore used for the coating for cooking pans. Coating of cooking or fry pans. Cooking or cooking of fry pans. Gaskets, we can also use for the gaskets or walls. These are usually in gasket or walls. So remember that Polytetrafluoroethylene is a very very important point. So polytetrafluoroethylene, it is also known as a Teflon. Monomer tetrafluoroethylene, structural formulas CF2 double bond CF2, it is addition polymer, it is a Homo Polymer. This is the reaction. Now see, CF bond is a very very strong, fluorine is a highly electronegative, carbon electropositive, therefore it is strong. It can't be affected by the chemicals as well as a high temperature, therefore it is used in the preparation of coating of the cooking pan or fry pans, gasket as well as walls or seals. It can be also used in seals. So these are the important points here. Now we are going to learn here the next one, preparation of condensation polymers. Condensation polymers. Again, you have to learn here the 4 condensation polymers. Again, you have to learn here 4 condensation polymers. First is the Nylon 6. Second is the Nylon 6. Third one is a Terylene. It is also called as a Dacron. And last one is a Bakelite. These 4 you have to learn in detail. So anyone has difficulty about the addition polymers? Ldpe, Hdpe, pan, polyethyl nitrate, and last one is tetrafluoroethylene, polytetrafluoroethylene. So see the addition polymers, that is the condensation polymers. First I will explain the term condensation. All these are heteropolymers, condensation polymers. They contains the bi or polyfunctional groups. First, nucleophilic addition of one molecule to the another molecule will take place. One will act as electrophile, second will act as a nucleophile. Therefore, this is a nucleophilic addition reaction. And then elimination of the small molecules such as water or alcohol take place. Therefore, this is called as condensation polymers. First, we have to learn here Nylon 6. Nylon 6. First, I will set the question of the nylon. The term nylon is the combination of the 2 terms. One is NY and second is LON. The NY stands for New York and this one stands for London. And see, the question will be set on the title. In the name nylon, the NY and LON indicates what? NY indicates New York and LON indicates London. Why this name is given to this fiber? Because the first time the discovery on the thread nylon was done into 2 cities, that is New York and London simultaneously, and hence the combination of the 2 terms will be derived there, and therefore the number. Then here this 6 and 6 indicates number of carbon atoms in the monomers. So first monomer, Nylon 6 is a condensation polymer. It is a condensation polymer. Second important question, it is a heteropolymer. Now see, in this case there will be the 2 polymers. One is hexamethylene diamine. The formula is like this: CH2 6 times NH2. NH2 2 times. Therefore diamine, 6 indicates hexa, CH2 indicates methylene. Therefore the name is hexamethylene diamine. Second is the adipic acid. It is a dicarboxylic acid. It contains CH2 4 times COOH. And see the number of carbon atoms. In this case 6 carbon atoms. Again in this case 6 carbon atoms, and therefore it is called as adipic acid. It is a dicarboxylic acid, and it is hexane 1,6-dioic acid. So this is the point here. Now see the question on the only nylon 6,6. NY, New York, LON, London. 6,6 indicates number of carbon atoms in the monomer. It is a condensation polymer. It is a heteropolymer. Two polymers will be there. One is a hexamethylene diamine. It contains 6 carbon atoms. Adipic acid contains again 6 carbon atoms. Count here 1 plus 4, 5 plus 1, 6 carbon atoms are there, and therefore it is the question here nylon N66. Now I will set the question on the preparation or synthesis of the nylon 66. It is a two-step reaction or two-step process. Nylon 66 is a two-step reaction or two-step process. Preparation of nylon 66. It is a two-steps reaction. Now see the step first. Step first is a neutralization, because amine is a base, adipic is acid. So you will do the reaction with adipic acid, HCOO CH2 4 times COOH. This is adipic acid. It is a dicarboxylic acid. Adipic acid is the common name. IUPAC name is hexane. 6 carbon atoms are there. 1,6-dioic acid. Then you will do the reaction with the hexamethylene diamine, CH2 6 times NH2. It is known as hexamethylene diamine. It is also known as hexane 1,6-diamine. See, it is a base, it is acid, therefore reaction is a neutralization, and you will get the salt here, neutralization. And see the salt here, OOC minus CH2 4 times COO minus NH3 plus CH2 6 times NH3 plus. See, this is a proton donor, this is a proton acceptor, so you will get here CO minus NH3 plus. Again proton donor, proton acceptor, you will get this one, and the name of this one is known as nylon salt. Then I will explain the step second. In the step second, nylon salt, N molecules, take here the N molecules of the nylon salt, COO minus, that can be also written as here O minus, C double bond O, CH2 4 times COO minus, then here NH3 plus CH2 6 times NH3 plus. When you will heat it, it undergoes polymerization under high temperature and pressure. Water molecule will be removed in this reaction, minus H2O, N molecules will be removed from here, and see the reaction here. This oxygen combined with the 2 hydrogen here, and you can remove the water molecule here, N number of water molecules. Similarly, this oxygen will be removed, 2 hydrogen atoms will be removed. On this side, you will get here C double bond O, CH2 4 times C double bond O. Then carbon will combine with the NH, and then CH2 6 times NH. This is N time, and the question is here on this point. This linkage is known as peptide or amide linkage. Peptide or amide linkage. So remember that nylon 6,6 is a amide linkage, contains amide linkage. Now see, this is the revision, and this is the preparation of the nylon 6,6. So I will take the revision on the nylon 6,6. First question on NY and LON 6,6, then monomers, Then why monomers contain the 6 carbon atoms? We should know it one. A preparation, it is a two-step preparation. First is the neutralization, second is polymerization. It is a condensation polymer, first nucleophilic addition and then a removal of water molecule. Then I will start here the second point, Nylon 6. So to the title, Nylon 6. Again here NY indicates New York. This LON indicates London. This indicates number of carbon atoms in the monomer. Here monomer is epsilon caprolactam. It is a cyclic compound. It is a 7-member ring compound. And see the structure of the epsilon caprolactam. C double bond O NH. 1, 2, 3, 4, 5, 6, 7 member rings here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 and 7 member ring. So this is the epsilon caprolactam. Now see why it is called as epsilon caprolactam. Why the term epsilon here? See this alpha, beta, gamma, delta, theta or epsilon. Epsilon is here. That is the amino group is present on the epsilon carbon atom. Therefore it is called as epsilon. Alpha, beta, gamma, delta. Alpha, beta, gamma, then delta and then epsilon. The amino group is present on the epsilon, therefore it is called as Nylon 6 is also called as Perlon. So remember this term, it is also called as Perlon. Now see the preparation here. C double bond O NH. This is the formula for Nylon 6. Remember that this is a CH2 carbon, CH2, 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 CH2. 1, 2, 3, 4, 5, 6 carbon atoms, and that indicates the number of carbon atoms in the monomer. When you will heat this compound at 553 Kelvin in presence of nitrogen gas inert medium, this bond will be broken here. Nucleophilic addition reaction will be take place here in this case, and you will get here the structure C double bond O CH2 5 time NH, and see this contains again En time here, and therefore it is Nylon 6. This is the formula for Nylon 6. It is a condensation polymer, it is a straight growth polymer, it is a linear polyamide polymer. Monomer used is epsilon caprolactam, and therefore this is the point here. Now see the uses of these polymers. Nylon. The nylons are used in making the brushes, scrubbers, saris, ropes, fishing nets, shirts, bed covers, toys, paints and coating industries. These are the uses of nylon. Now I will start the point terrorism. So give the title terrorism. It is also called as a diachron. It contains the ester linkage. The formula for ester linkage is a COO. This is the formula for ester linkage. Second point, it is a heteropolymer. There are the two monomers. The first monomer is Eg, long form of Eg is ethylene glycol. Ethylene glycol. And second one is DMT, dimethyl terphthalate. Dimethyl terphthalate. Now see the preparation here. So these are the points here. Preparation of the react. So it is a two-step reactions. So I will explain the step first. Reaction between ethylene glycol. Ethylene glycol has formula CH2 double bond single bond CH2OH. This is the formula for ethylene glycol. It will react with the DMT, dimethyl terphthalate, CH3O, C double bond O, benzene ring, C double bond O, OCH3. This is the dimethyl terphthalate. We will use here N molecule of this one, N molecule of this one. Then nucleophilic addition and elimination reaction will be take place. You can remove here N molecules of methyl alcohol. Methyl alcohol. Here catalyst used is zinc acetate, and antimony trioxide and antimony trioxide. These are the catalysts used here. So you will get here N time OH, CH2O, C double bond O, then benzene ring, C double bond O, CH2 O is here, CH2 OH. I can see here you can use here the another molecule here OH, CH2 OH. You can remove the here ethylene molecule. So this is the point here. Then it undergoes step second, polymerization reaction, and you will get here ester, and that is known as polyester. Now see, it undergoes step second. I will indicate here step second, that is the polymerization. This underlying part combined with this part, you can indicate here ethylene glycol, and therefore you will get the structure here O, C double bond O, benzene ring, C double bond O, CH2, N time, and this is called as a terry. It is also called as a polyester. We should know the terrycot. It is a, when cotton is blended with terylene, it is called as a terrycot. Terry wool, when wool is blended or mixed with terylene, it is called as a terry wool. Now see, terylene absorbs very little water, hence it dry quickly. It is dry quickly. So this is the points here. Now I will start the remaining part in the next lecture. Okay, thank you.